Hello, let's continue the tutorial on menstruation 2. A question to that regard. So the dimension of a cuboid are 20 centimeters, 30 centimeters, and 60 centimeters. So we have to find the length of the longest stick that can fit into the cuboid. So you take a cuboid, you put a stick in it. That stick is going to serve as the diagonal. So if you put a stick in the cuboid, it will serve as a diagonal. So you're only looking for the length of that diagonal. Let's make a sketch and see how we can do that. Good. So if this is the cuboid we are having, 20, 30, 60 could mean any of the dimensions, length, breadth times the height. The height can also be long, but in this case, as we are having our dimensions, we can see the longest side to be the 60. So let's just say this is our 60 centimeter, this is our 20 centimeter, and this is our 30 centimeter. So they are all going to be jump up or mix up in order to find the length, breadth, and what? The height. Now, the longest stick that can fit into this could be from this corner to this corner, or from this corner right down to this corner. So the formula is just the square root of all the three sides. But we can also see it to be, if I want to find the length of, let me just put A, B, C. So AB. I first need to know the length of what? BC. And also to know the length of what? AC. For AC, I can find easily. AC is the same as the 30 centimeter. So in this case, our 30 will be there. How about this side? This side is also the diagonal of the rectangular base. The formula is there, but we want to derive it. So you can see the rectangular base. This is also going to be 20. The longest side is going to be 60, right? Where we know every rectangle has the angle at the corner to be 90. So this form what we call a rectangle, which is right angle. So this becomes the diagonal, right? So let me label this one A, B, C, D. Let's just say we have E, F, G, H. So if I take the triangle C, G, H, I can use the Pythagoras theorem, right? So from the triangle C, G, H, we can find the side here. Let me use X. We can find X squared, which is the diagonal, as our hypotenuse, right? Equals to 20 squared plus what? 60 squared, right? That will be for this side. And if you are looking for the X, that will just give you the square root of 20 squared plus 60 squared, right? It means I know X. I can now find the red line, which is Y. And this is also going to be hypotenuse. The line from here form 90 degrees at the base there. So using the Pythagoras theorem, so we can say from the triangle AGC, we can have the Y squared equals to the X squared, right? Plus the 30 squared. We see that? So we can say Y squared equals to X squared. Let's even leave this. This is our X squared, which is 20 squared plus 60 squared. This is the X squared here. Then our 30 squared. So in the beginning, I mentioned that the square root of the square of all the dimensions will give us what we are looking for. So this becomes the root of 20 squared, which will be 400, 60 squared plus 900. And that will give us the root of 4,900, which we know 70 times 70 will give us this, So that will give us what? 70. What is the dimension? Centimeter. Right? So the length of the longest stick that can fit into this is this. But on the normal, the length of a diagonal is always the root of the length squared, the width squared, plus what? The height squared. So if you are looking for just a formula without understanding, without breaking the rectangle or the cuboid into pieces to find the values, you just go ahead. The length of diameter of either a cube or a cuboid will be the square root of the squares of all the three dimensions. I guess from today, you will not bother yourself with this calculation, but use the direct formula. Thanks for watching. Bye-bye.